All right, grade 5, we're going to move on to our next lesson. This is going to be lessons 3 and 4. It says 3 and 7, but that's a mistake. It's 3 and 4. We're talking about perimeter and area. Perimeter and area you learned about last year, and they're assuming you remember a lot about it. So we're going to do some review before we move on to what they want you to do with it in our grade 5 curriculum. Just again, a reminder, our big idea is that objects have attributes such as length, area, perimeter, and volume or capacity that can be measured. Measurements of the same attribute can be used to compare objects. So today we're going to be comparing area and perimeter, not volume. I've taken that part out and made it a separate lesson. It's too much all at once. So area and perimeter is what we're going to look at. So again, reviewing what area and perimeter are, remember that perimeter is the distance around the outside of the shape. It is measured in units such as millimeters, centimeters, and meters. If you wanted to, you could look at it as a formula, and you would be measuring perimeter equals side 1 plus side 2 plus side 3 plus side 4. Or you can look at it as length plus width, multiplying that by 2, because there's another one, and that would get you your perimeter as well. So let's take a look at this rectangle and let's figure out our perimeter. So if we have a length of 1, 2, 3, 4, 5, 6, 7, we have a length of 7 and a width of 3, what would our perimeter be? Well, using either formula, 7 plus 3 plus 7 plus 3, 7 plus 3 is 10, 7 plus 3 is 10, 10 plus 10 is 20, and we're going to assume these are centimeter squares. They look like they're about a centimeter if I estimate with the width of my pinky. So 20 centimeters. If we were to use our length plus width times 2 formula, 7 plus 3 times 2. 7 plus 3 equals 10 times 2 equals 20. Both equal the same thing. So that's our perimeter, our distance around the outside edge. The other thing we're going to look at is area. Area is the amount of two-dimensional shape a surface covers. So it's the amount of space used to cover a surface of a two-dimensional shape. And remember, a two-dimensional shape is a flat shape. So we're not looking at 3D shapes, we're looking at flat shapes. It is measured in square units because really what we're looking at is the number of squares it takes to cover that space. So it is written as centimeters squared or millimeters squared with that little 2. So centimeters squared like that with that little 2. One of the ways that it helps me to remember it is if I think of it, it's looking at a 2D shape, so it's a 2 there. Okay. So again, area measures the amount of space inside of this flat shape. To find it, we use the formula area equals length times width. So we multiply length times width. I know some of you are still counting your shapes or your squares, but this time in our unit, we're going to get to the point where we don't have shapes with squares in them. So I'd like you to move towards using the formula length times width to figure that out. All right, so let's take a look at our shape. Again, it had 7 centimeters on one side and 3 centimeters on the other. So for area, it is length times width. Might not be a bad idea to start using these formulas. That's part of what you'll be expected to know in grade 6. Plus, if you always write the A equals or the P equals, it helps you to separate what is area and what is perimeter so you don't mix them up, which is also a common mistake. So length times width, 7 times 3, which would make it 21, and it's centimeters we said, and it would be squared because it's centimeter squares that are covering it, square centimeters. And if we were to count this, we would see that we would get 21. 7 plus another 7 is 14, plus another 7 is 21. So we would have 21 squares covering that shape. That is area. So just a quick review of what area and perimeter are and how to find them. All right, and just to practice, we're going to find the area and perimeter of the following rectangles. Make sure to show your work on a separate piece of paper, please. Work and answer so we can figure out if you've made a mistake, what the mistake was. Go ahead and try these for practice now. All right, let's take a look and see how you did. So number 1 we'll take a look at. We are going to find the perimeter first, and I'm going to go length plus width plus length plus width. So it is 5 plus 4 plus 5 plus 4, which is 9 plus 9, which makes it 18, and the units are meters. Now for the area of this shape, it is length times width. So that would be 5 times 4, which would make it 20 meters squared. In case I haven't mentioned, you are able to use your calculator throughout this entire unit, but you do need to show work like this. You need to have your work, and you need to have your answer, and it must include the units. As I said, the formula itself is part of what is grade 6, so it's not necessary, but I would recommend getting into the habit. You're going to need to know how to do it next year anyway. So, all right, we have the perimeter, the distance around the outside edge, and we have the area, the space inside this 2D shape. Let's try it for 5. And number 5 here, perimeter again. This time I'm going to go length plus width, not times, be careful. Length plus width times 2. So I'm going to go 8. Oh gosh, let me erase that. That looks quite like an awful 8. Let's fix it. 8 plus 2, which is 10, times 2, which is 20 meters for our distance around the outside edge. Now for the area, always length times width when we're talking about rectangles or squares. 8 times 2, which would be 16. And our units are, millimeters. Be careful, I made the mistake up there. Millimeters squared. So 16 millimeters squared would be the amount of space inside of my 2D shape for that one. All right, let's take a look at this number 9 one here. Perimeter again. I'm going to go length plus width plus length plus width. So 6 plus 8 plus 6 plus 8. 6 plus 8 is 14. 14 plus 14 is 28 millimeters would be our perimeter. For area, it's always the same length times width. So 6 times 8, which is 48. And it is millimeters squared because it's how many square millimeters would be used to cover the inside of this 2D shape. All right, let's take a look at the second row of squares. So number 2 is the one we're going to look at. Perimeter, again, distance around the outside shape. Length plus width plus length plus width. So 8 plus 4 plus 8 plus 4. And really the order that you do these in makes absolutely no difference whatsoever. Thinking of the commutative property for addition and multiplication, doesn't make any difference what order you add these in. 8 plus 8 I'm going to take, just to show you that it won't make a difference, is 16, and 4 plus 4 is 8. And then I can take a look. 6 plus 8 is 14, plus the other 10 would make it 24. And it is metered and it is not squared because we are not finding out how many squares. We're just finding out how many flat centimeters it takes to go around this rectangle. Area, however, length times width, is finding out how many meter squares, so squares that would be 1 meter on each side, it would take to cover this shape. So 4 times 8 equals 32, and it would be meters squared to cover the flat surface of that shape. All right, let's take a look at number 6 here. Perimeter again. I'm going to go length plus width times 2. And we do have to have the length plus width in brackets. Because what we do in what's in brackets, we actually have to do first. And that's going to be something you learn about a little bit more next year. But it's a good habit to get into. 9 plus 10 would be then in the brackets. 9 plus 10 is 19 times 2 is 38. And it's millimeters this time. For area, length times width, no other way to find area of a rectangle. 9 times 10, annexing 0, 9 times 1 is 9, add the 0 back on, 90 millimeters squared. And the last one for our practice of area and perimeter, number 10, perimeter, length plus width plus length plus width. So 7 plus 8 plus 7 plus 8. 7 and 8 is 15. 15 and 15 is 30, so 30 centimeters. For area, length times width. 7 times 8, which is 56, and it's centimeters squared. Perfect, so that's your practice for area and perimeter. Now, the big thing that you need to be able to do as part of the grade 5 curriculum is you need to be able to design and construct different rectangles given a perimeter. So if I ask you to create a rectangle that has a perimeter of 18 centimeters, you need to be able to do that. So let me show you how our formula here can help us with that. We have two groups of the length times width, right? So if we have 18 as our perimeter, that means we need to take 18 and divide it into 2, because if you look at our rectangle, we know that if we divide it into 2, the lengths are the same, the widths are the same. So we have to divide it by 2, so it would be 9. And now we're looking for something and something that's going to equal 9. So that's your key for creating those rectangles. Well, what plus what can equal 9? Well, if we take a look at our examples over here, we have 8 plus 1. That equals 9. That's a possible rectangle. We could have 2 plus 7. That also equals 9. That's our other possible rectangle. 2 plus 7. 8 plus 1. Here we see 3 plus 6. And I hope you're starting to notice a pattern here. And here we're going to see 4 plus 5. Okay, and as you can see, there is a pattern. It's 1, 2, 3, 4, 5, 6, 7, 8, all the way up to 9. And when we figure out that these actually do have a perimeter of 18, we can see that those are all possible rectangles. So if we look, 8 plus 1 is 9, plus the other 9 on the other side is 18. Yes, it has a perimeter of 18. Let's check this one. 2 plus 7 is 9. Plus another 2 and another 7 is 9. 9 plus 9 is 18. Yes, it has a perimeter of 18. 3 and 6. 3 plus 6 is 9. 3 plus 6 is 9. 9 plus 9 is 18. 4 plus 5 is 9. 4 plus 5 is 9. 9 plus 9 is 18. That's all the rectangles we can create. We can't come up with anything else. We always want whole numbers on the side, no decimal numbers. So these are the possible rectangles we can find that have a perimeter of 18. Now, they all have a different area. Okay, so if we look, 8 times 1 has an area of 8 centimeters squared. 2 and 7, 2 times 7 is 14 centimeters squared. 3 and 6, 3 times 6 is 18 centimeters squared. And 4 and 5 is 20 centimeters squared. From this, we can have a generalization that will help you throughout the unit or throughout the lesson. The rectangle with the least width, the long, skinny rectangle, has the least area, the smallest area. The rectangle that is closest to a square, the most square-like rectangle, has the greatest area. That's going to be important. That's going to help you later on. All right, now you get to do some practice. On some grid paper, I would like you to find and create as many rectangles that have a perimeter of 8. Once you've found all of the possible rectangles, not leaving any out, that have a perimeter of 8, find the area of each one. Tell me which one's going to have the largest area and which one's going to have the smallest area. So you're creating all the possible rectangles that have a perimeter of 8, finding the area of each, telling me which is the largest and which is the smallest. Press pause and go ahead and do that now. All right, so if we are looking for rectangles that have a perimeter equaling 8, remember we have to divide 8 in half to figure out what those sides would be. So 8 divided by 2 is 4. So that means we need something plus something that's going to equal 4. Well, let's start with 1. 1 plus what equals 4? 1 plus 3 equals 4. Perfect. I'm going to draw a 1 by 3 rectangle. Let's double check. Does it have a perimeter of 8? Well, 3 plus 1 is 4, plus 3 plus 1 is 4, 4 plus 4 is 8. Yes, it does. Let's see what else we can draw. 1 plus 3, what about 2 plus something? 2 plus 2 equals 4. Okay, let's draw that rectangle. It's actually a square, but that's fine. Rectangles or squares are a kind of rectangle. 2 plus 2, let's check. Does it have a perimeter of 8? 2 plus 2 is 4. 2 plus 2 is 4. 4 plus 4 is 8. Perfect. What else could I have? Well, I could go 3 plus 1. Oh, I already have that. That's this same rectangle. It's just drawn differently. So if I draw my rectangle like this, or I draw my rectangle like this, it's the same rectangle, it's just actually turned. So we don't need to draw that one. There's really only 2 possibilities here. Now you are asked to find the area of each. Okay, so the area here is going to be length times width. What is my length? My length is 3 times 1 is 3. So 3 centimeters squared. My area for this one, 2 times 2, length times width, 2 times 2, area of 4 centimeters squared. And sometimes you'll notice your area and your perimeter are the same, and that's fine. Does this follow my generalization? Is my long, skinny one having a smaller area? Yes, it is. Is my more square-like one, or in fact square in this case, having a larger area? Yes, it does. So that can help us when we're doing some problem-solving questions and such. Now, the other thing you need to be able to do is you need to be able to design and construct rectangles with a given area. So if I give you the area, you need to come up with a possible rectangle for that. So for example, here I'm finding the area of rectangles, with an area of 16. Here our formula helps us again. Our area is length times width. So that means we need, if our area is 16, we need something times something that's going to equal 16. So let's take a look at what we have as possibilities. This one doesn't have quite as nice a pattern as perimeter, unfortunately. Basically, this is your factors. Remember all of the numbers that multiply to equal 16. Well, always 1 times something. 1 times 16. So 1 times 16 we see here. 2 times something equals 16? Yes. 2 times 8 equals 16. 3 times anything? No. 4 times anything? Yeah. 4 times 4 equals 16. 5 times anything? No. 6 times anything? No. 7 times anything? No. 8 times anything? Well, 8 times 2, we already have that. Same thing. If we were to draw it up and down or side to side, it's the same rectangle. It's just turned, so we don't need that. So then we know we are done. There are 3 possible rectangles. Now we're going to look at the perimeters of those. All right, so to find out the perimeter of each, remember we have to add. So 1 plus 16 is 17. And 17 plus 17 is 34. So it has a perimeter of 34. Looking at this next rectangle, 2 plus 8 is 16, and 2 plus 8 is 16. No, sorry, 2 plus 8 is 10. I'm thinking 2 times 8, my apologies. 2 plus 8 is 10, plus 2 plus 8 is 10. 10 plus 10 is 20, and our perimeter is 20 centimeters for this rectangle. And our square-like rectangle, 4 plus 4 is 8, plus 4 plus 4 is 8, so it has a perimeter of 16. So now it's exactly opposite. The rectangle that is more square, the rectangle that is more square has the least perimeter, and the rectangle that is long and skinny has the greatest perimeter. Again, another generalization that can help you. All right, now you're going to do some practice, and you're going to create rectangles that have a given area. You want rectangles that have an area of 8. Once you've found those rectangles, find the perimeters of each of those rectangles. And we'll see if the long and skinny really does have the largest perimeter and the more square-like has the smallest perimeter. All right, so go ahead and press pause and find all the rectangles, all, not just some, all of the rectangles that can have an area of 8. Go ahead and press pause and do that now. All right, so area we know is length times width. So we need an area of 8, which means we need something times something that's going to equal 8. Well, 1 times something definitely equals 8, because 1 times something always equals that answer. So 1 times 8 we could have. That's a long, skinny one. So 1 by 1, 2, 3, 4, 5, 6, 7, 8. There's our rectangle. Sorry, it disappeared for a second. Okay, could we have 2 times something? Yeah, we certainly could. We could have 2 times 4 equals 8. Okay, let's draw that one. 2 by 4. All right. 3 times anything equal 8? Nope. 4 times anything equal 8? Yeah, 4 times 2. Oh, we have that already. That's just turning that shape, so we don't need that. So these are the only 2 rectangles we can find. So let's go ahead and look at the perimeter of each one. Here, if we have 8 plus 1, that's 9, plus 8 plus 1, that's 9. So 9 plus 9 equals 18. So it would have a perimeter of 18 and an area of 8. If we look at this one, we have 2 plus 4 plus 2 plus 4, which is 8 plus 8, which is 16. So 16 would be our perimeter for this one. Does our long, skinny rectangle have the largest perimeter? Yes, it does. Does our more square-like rectangle, and of the 2, it is the most square-like, even though it's not overly squarish, have the smallest perimeter? Yes, it does. So now we can use this to help us when we are trying to find answers specifically to problems. I'm thinking of problems related to fences, which would be the perimeter. So if I were trying to build a yard and I want as much space inside my yard as I can, I don't want very much fence, I don't want to build a lot of fence, I don't like building fences, I'm going to want a large square-like shape, because then it gives me lots of space inside, lots of area, small perimeter. Perfect. That would be the kind of situations that you're going to find this helpful for. All right, so let's review. A long, skinny rectangle is going to give you a large perimeter, a large distance around, but it's going to give you a small area. a smaller space inside. The more square-like rectangle is going to give you a small perimeter, not as much space around the outside, but it's going to give you a large area. Lots of space inside. Okay. That is about it, I believe, for this concept. So, I mean, there was a lot here, reminding you what area and perimeter are, being able to create a rectangle that has a specific perimeter, being able to create a rectangle that has a specific area, and then being able to make these generalizations that a long skinny rectangle is going to have a small area and a large perimeter, and a square-like rectangle is going to have a small perimeter and a large area. All right, so now that we know that, we're going to do a little bit more practice because this is kind of a tough concept and a lot in here. You're going to create a rectangle. Create a rectangle that has an area of 24 centimeters squared and it has a large perimeter. You are also going to create a rectangle that has a perimeter of 12 centimeters but a large area. All right, so let's take a look. We would like a rectangle with an area of 24. So if we know about area, we know area we find by going length times width. That means we need something times something that's going to equal 24. Well, what are our possibilities? Of course, 1 times 24, 2 times something, yes, 2 times 12, 3 times something, yes, 3 times 8, 4 times something, yes, 4 times 6, 5 times something, no, 6 times something, yeah, 6 times 4, I already have that, Kate, I know I'm done. Now these are all my possible rectangles, but I want the one with the largest perimeter. If I want the one with the largest perimeter, that means I would like to have a long, skinny rectangle. Well, which one is going to give me the longest, skinniest possible rectangle? Well, 1 by 24 is going to give me my longest possible skinny rectangle. So I didn't have to now find the perimeter of each and every shape. I only needed to find the perimeter using the generalization that I already have, that a long skinny rectangle gives me a large perimeter and a smaller area. Well, here they all have the same area, so I'm just looking for the largest perimeter. The largest perimeter is going to be the long skinny rectangle. So 1 by 28. All right, now we need to make a rectangle that has a perimeter of 12 and we want the largest area. So perimeter, again, remember, is length plus width times 2. So if my perimeter is 12, then I know I'm going to have to do the divide by 2, the opposite, to figure out what my length and width are. So divide by 2 is 6. So then I need something plus something that's going to equal 6. What plus what can equal 6? Well, 1 plus something. 1 plus 5 equals 6. 2 plus something, yeah. 2 plus 4. 3 plus something, yep. 3 plus 3. 4 plus something, 4 plus 2. Oh, I've already got it. I'm done. Okay, so these are my 3 possible rectangles. If I want the largest area, long skinny rectangle, is that largest area? No, long skinny is smallest area, largest perimeter. More square-like is largest area, smallest perimeter. I want the largest area, so I want the one that's most square-like. Well, lucky me, here's one that's actually going to be a square. 3 by 3 would be the one that would have the largest area. So I don't actually need to do all of the work to make that happen. I can use the generalization to help me figure that out. All right, that takes us through the whole lesson. I know that was a lot in that lesson. Remembering what area and perimeter are, being able to create rectangles that have a certain perimeter, being able to create rectangles that have a certain area or a given area, and then being able to figure out which one's going to have the largest perimeter, the smallest area, the largest area, the smallest perimeter, and so on. So, your practice today for perimeter is page 103, numbers 2, 3, and 8. And for area, page 133, numbers 1, 4, and 5. Remember to show your work. Remember, you are welcome to use your calculator, but using your calculator doesn't mean that you don't show work. You still do. So for example, if we were doing area, you would still have to say 3 times 8 and then equals 24, and this would be your work. Don't forget your units. That's going to be important too. Okay? If you have questions along the way, of course, please remember to ask. All right, and when you are finished, you can choose one of these open questions. Pick whichever one you'd like, copy it down, and answer the question. They are about, of course, finding a particular rectangle with a given perimeter or a given area and determining which one would be best based on if you want the greatest possible perimeter or area or greatest or smallest possible of each. All right, away you go.